Okay, session 10. We're doing a little bit more algebra today on indices. So we're going to look at some secret quadratics and a bit of proof. This is chapter 4. A lot of this will be recap actually from GCSE, so you'll find this okay. And let's get straight in. Okay, so let's start with indices. And let's just recap the rules of indices. This will take you back. GCSE rules. So we've got A. If you had a situation like that, it would just be A to the n plus n. Rule 1. Rule 2, if we've got division, you subtract the powers. If you've got something like this, with say if it was a 2 in there and you to the power of n, you've got to remember to do 2 to the n and then you multiply the powers. What else have we got? We've got something like anything to the power of 0 is 1. That's going to be really useful for the exercise on the last question. We've got anything to something like a half or a fraction is like a square root or a root of a certain value, and anything to a negative power, say if it was minus 2, it's 1 over a squared. Okay, so those are the rules. Those should be a recap really from GCSE. So six rules of indices. Right, we're going to go straight in with an example. So e.g., write as a single power of x the following. So write as a single power of x, massive square root, x to the 3 over 2 times x to the half over x to the 3 all squared. Okay, so you might want to pause the video. When it says write as a single power of x, that means we're trying to get to an answer x to the power of something, and that's what we're trying to work out. Okay, that's what the question is asking. Right, how I would approach this, well, I'll just break it down. So let's keep the square root as it is for the moment, and let's just work out what the top would be. If I add those, 3 over 2 add a half is going to be 4 over, that's actually going to be 4 over 2, which is 2. And the bottom, you multiply the powers, get 6. Okay, let's keep going. I can minus the powers there. 2 minus 6 is minus 4. I've still got a square root. Square root is the same as doing to the power of a half. That's the same thing. So then I multiply the powers and it's x to the minus 2. So all of that just becomes x to the minus 2. That's our answer for that question. Okay, so that's writing as a single power of x. e.g. we might be asked to solve something like this. Solve x to the minus third equals 10, and this would be in a non-calculator paper. Solve that. So we're trying to work out what x is there. Now the best way to do this, you're trying to get to a point where you're trying to get to x is equal to some number. That's what we're trying to work out, and that's really x to the power of 1. We're trying to work out what do I need to do to get from x to the minus third to 1. And in order to do that, I need to raise it to the power of, I need to think, okay, what do I need to times by minus a third to give me 1? Well, that's going to be minus 3. Okay, just take your time to realize minus a third times minus 3 does equal 1. So I need to do that for the same on that side. Okay, so that makes me x to the 1, which is what I was after, because I multiply the powers. 10 to the minus third is 1 over 10 cubed. So my final answer, I can get rid of the 1 on that side. It's 10 times 10 times 10. The answer is 1 over 1,000. Okay. Right, so that is a bit of a recap on indices. You're going to do a bit of practice on that in a minute. But we're going to move on to part 2 of the session, which is secret quadratics. One of my favorite areas of maths. Secret quadratics. And the best way to do this is to look at a couple of examples. So e.g. 1, solve x to the power of 4 minus 5x squared minus 4. Okay? Now you'll be right to say, well, this isn't a quadratic. Look, there's a power of 4. It's actually what we call that is a quartic. But I can manipulate this to make it a quadratic. If I make it all equal to 0, which is how we solve all quadratics anyway, okay, I can now do a clever substitution. I can say let y, it doesn't have to be y, any letter, equal x squared. Now if y equals x squared, x to the power of 4, well, if we just put over here a bit of side working, x to the power of 4 is the same as x squared squared, which would be the same as, well, we know, y squared. So I can rewrite this equation as y squared, that's the x to the 4, minus 5, or x squared is y. The 4 doesn't change. Now I've made it a quadratic, so I've turned my non-quadratic into a secret quadratic. And I would solve this as usual, and I look to always, if I can factorise, I will factorise. So y, 4, or 1. Now, I don't stop there because my question was working out what x was, not what y was. But I know that y is x squared, so therefore x squared equals 4, or x squared equals 1. I just replace the y with x squared, and then I can square root both sides. X will equal, now be careful here, plus or minus 2. It's got to be plus or minus 2. Or if I square root both sides here, x equals plus or minus 1. And there are my answers. I've got 4 answers, 2, minus 2, 1, or minus 1. Right, one more example, then you're going to do some questions. EG2, solve 4 to the x equals 2 to the x plus 56. Okay, and again, you would be right in thinking, well, this doesn't look like a quadratic, and it isn't really a quadratic, but we can change it. So I'm trying to get all the same base, so I need to get them all to the same base. What I mean by that is I need to get them all really to 2 to the power of something in this case. And I know that 4 is equal to 2 squared. So let's replace 4 with 2 squared. X equals 2 to the x plus 56. Just going to rewrite this one to 2, because it doesn't matter, I can flip these round the other way. So it's actually 2 to the x squared equals 2 to the x plus 56. I think what I probably should have done earlier is to make them all equal to 0, but I can do that now. 2 to the x squared minus 2 to the x minus 56 equals 0. Now it's starting to look a little bit like a quadratic. Now you may want to pause the video and sort of see, well, what would my substitution be? Well, my substitution here, if I let y equal 2 to the x, well then I'm in a really good position, because wherever I see a 2 to the x, I put a y. So this is going to be y squared, that's just minus y, minus 56, equals 0. And I can factorise that as usual. Y, what's that going to be, minus 8, and then y plus 7 equals 0. So my two answers for y are 8 or negative 7. Remember, I don't want to know what y is, I want to know what x is. So I go back in, 2 to the x equals 8, or 2 to the x equals minus 7. Now that is just quite clearly 2 cubed, so x is equal to 3. 2 cubed is equal to 8. Over here, there's not going to be any, well, 2 to the power of x equals minus 7. Now, there's a few, you can get this, I mean, in an exam, it'd probably be nice numbers, because it'd be a non-calculator. You can really get that with a bit of trial and error there. I'm not going to, nice. Yeah, sorry, in that question, it did say x has got to be, at the very start, it said x was greater than 0. So for that particular equation, there's no solution. Because x is bigger than 0, it said I'll say in the question up here, x is bigger than 0 there. Okay, so our answer to that is 3. Right, I'm going to do a few questions on that. So page 105, exercise 4F, and it's question 1 to 9. Question 1 to 9, and I want you to do the first and last part for each section, for each question. Okay, so the first one is an easy one. You should be able to answer that quite quickly, and the last part is a little bit trickier, but take your time and you'll be fine. So pause the video, work through those before we move on to the last section of this week's session 10, which is the proof section. Okay. Right, final bit today is looking at some algebraic proof. Now proof, there's a few different ways. Definitely look at the examples examples on page 107, because each question is slightly different here. I'm going to work through a couple of them with you now. Hopefully that will help. So let's look at EG1. Show that x squared minus 8x plus 18 is always positive. Okay, show that x squared minus 8x plus 18 is always positive. So whatever value of x I put in there, I will get a positive outcome. That's what I'm trying to show. Best way to show something is positive when you've got a quadratic is to complete the square. Okay, so complete the square for this function. Now what I'm going to do for that, so that becomes x minus 4, and we half that squared, minus 16 plus 18. So that becomes x minus 4 squared plus 2. Okay. Now you can say anything squared, so x minus 4 squared has got to be bigger than or equal to 0. Because anything squared, the smallest that can get is 0, so that's got to be bigger than 0. Therefore, x minus 4 squared plus 2 must be bigger than or equal to 2. Therefore, always positive. Okay. So you complete the square and you show that if that was a negative, then it would be not the case. But because it's plus 2, you're okay. It's definitely always positive. Okay. Right. EG2. We'll have one more example. So let's say f of x equals 2c plus cx over 2d plus dx, and it says c is bigger than d and d is positive. Show that fx is always positive. Okay, that's the question. So it tells us fx is that. Show that fx is always positive. Right, whenever you've got an algebraic fraction, always try and factorise it if you can. So fx, I can factorise this. See, 2 plus x over, I can take a d out, and 2 plus x. And I can simplify that. So that becomes c over d. fx is c over d. Now, it says that c is always positive and the question and greater than 1. Okay, so always positive and greater than 1. Well, it tells you in the question, so c is bigger than d, therefore fx is great. It's got to be greater than 1, as c and d will be positive. It tells you in the question they're positive. And because c is bigger than d, it's got to be, that function there has got to be greater than 1. That is how you would answer the question. Okay? Right, so page 108 now, I do want you to do the even, so questions 2 to 10, but do not do question 4, just the evens only. Okay, this is a key topic for GCSE as well, so you're doing some GCSE revision. All of this session is going to help you with the GCSE. There you go. I will see you. We've got probably 2 more sessions before we finish chapter 4. Okay. See you soon, guys.